along. You have reached Russ Grease with RWG-Research.com. Open-source-energy.
Okay. Crap. Welcome to the shop where things never stop. Video series RWG-OSD. Oversized Delta.
Footage recorded on January 9th, 2016. Hey, what's up everybody? Russ with RWGResearch.com here. Alright, so this is the wire EDM machine, as you can see. I'm going to basically run you through how I made the skate plates, as I'm going to be calling them for the most part, in the 3D printer build.
Alright, so briefly I wanted to discuss what this machine is. This is a wire EDM machine, electrical discharge machining. It's a non-contact machining. And basically, the interesting thing is as long as the material is conductive, you can cut it. And you can cut it without actually touching it, which means you could cut very thin material very precisely. So I want to show you what is really going on here. So under this cover is a nice spool of 0.05 millimeter brass wire. And it is basically fed through this machine, up through these rollers. It runs through a switch here so it knows it's not broken. It also runs through a cleaning pad which wipes any dirt off. Comes around here to the ceramic wheel which actually grabs it. This is actually what moves the wire. And then another wheel, there's a laser here which is also a sensing device as well as another guide so that we know it's not broken. The machine knows it's not broken. And then it runs down into this what they call an AT, automatic threader. And this also can pop open. There's a couple rollers in here, pinch rollers and the guides. A cutoff. This is an electrical cutoff so that if you want to break the wire, it actually breaks the wire through high current. And a couple more rollers, and then there's a ceramic nozzle. It's actually an alumina ceramic nozzle which comes out through the bottom, and then on the back side of the machine where the wire is actually disposed of, it comes out looking like this. And you can see, I don't know if you can see the difference in color. This is probably, well, that's actually been used. There's a fresh piece of wire right here. And this is the used wire. You can see how dull it is. That's because it's actually being burned away very slightly. And that is actually how the machine cuts.
So first thing we did is we used a program called Google SketchUp. Nowadays it's not Google SketchUp, it's SketchUp Make. In that program I just basically laid out the basic hole pattern where I wanted to put the holes and stuff, and then using a different software which is called BobCam. It's an okay software. It's basically a software designed for different types of CNC machining. So since I'm going to be using a wire EDM machine, this worked just fine for my application because that's what it's used for. You got to basically draw the part and then trace. You select the lines at which you want the cut to be. Then you program everything to do different styles of cutting. You want it to be flush, you want it to come in at an angle. How precise do you want it to be? Do you want to come back and skim it a few times to make it even more precise? And then after that, you basically export it and it turns it into a .cn file, which is basically a G-code file. So it's identical to what the 3D printers is running, except this G-code is formatted for this machine. Alright, transferring via flash drive. Let's go.
Program's good. I'm happy. It's happy. Every once in a while it can be tricky to get the code just right, but looks like we did a good job. So now we're going to set it up and get ready for the cut. This is my template. I cut it out of paper to scale just to find out exactly where I want to lay this without guessing too much, make my life a little bit easier. So we'll mount this plate in there and we'll do a dry run and make sure everything lines up correctly and see what happens. Oh, before I do that, I'm going to rough the edges off because this is an iodized piece of aluminum and it's non-conductive. The material must be conductive for it to actually cut. So I'm going to clean these edges off so we don't have any troubles with that. Should be good. Recycled aluminum off of something I took apart at one time. Got some measurements. This was actually a film camera plate for high-tech film back in the 90s. About a $50,000 machine. I tore it apart. I've been using scrap for years. We're going to remove the edge off of this plate. It's black right now. Hopefully we don't have black when we're done. So, first thing I need to figure out is how to not lose my template. Let me grab it. Alright, so I want to be able to cut 3 of these efficiently. So what we will do is just sort of mock them up using a pencil, lightly sketch. Pencil with lead, that is. So, just using a pencil, sort of gonna lightly mark out the maximum dimensions on here so I can make sure I can fit several of these. You always want to get the maximum potential out of your material, so this is a good way of doing it. Okay, so we're gonna probably end up cutting this piece off because we really don't have much room to work in this machine. It's kind of small, and so we'll just cut this off so we have a little easier piece to work with. We're gonna try to use one of these cutoff wheels, but it's aluminum, so it might not work the best. Let's give it a shot. It cut all the way through better than I intended, so that's great. We'll cut this one. Slam, bam, you know the rest. Lightly clean up this edge so we don't have to worry about it sticking past the table on our CNC EDM. Ooh, pretty touchy-feely. I'm going to rough this edge off too so that we don't have to worry about that coating also on this side. Alright, so we'll try this disc. It seemed to cut well, so it should take this finish off a little faster. Cool beam. According to my drawing, we're going to be coming into the sort of top point right there, so which will be about right here approximately. And I just want to be able to make sure I use up my material wisely, so I think I'm actually going to start the cut like this, which will be the best. There's a hole here in this plate which I'll need to not cut. I want to go and make sure the plate is fresh and new, no holes or anything, because this is recycled material. I like to do everything recycled material. So I'm just going to mark this, and what we're going to do is get the tool here, the wire, lined up with this, do a dry run, and then we'll attempt to machine this and see how it turns out. First we're going to clamp the plate down though. Okay, so because this machine is so delicate with how it cuts, it's actually non-conductive or non-contact machining. So tightening these holders down with my thumb is actually enough to hold this plate in place, but we won't trust that. We'll go ahead and give it a little snug tight with the tool, but it's pretty interesting because it won't move even with that slight hand tightening, because the wire that's cutting this plate is actually not touching it, the material is being removed with a electrical discharge between the wire and the part, which is pretty cool. Really, really cool. Okay, so right now my table is orientated this way according to my plate. So what I can do is actually turn the entire axis at a 90-degree angle here, and that will allow me to cut this plate at the orientation that I have it. I can do any angle in between, but I'm just going to do 90 because I got my plate aligned fairly straight on that direction. Okay, I'm going to rotate the table right here. So using a axis rotation, we are basically going to rotate the entire table at a 90. At a 90. There we go. Now when we go back to look at our piece and check it again, hopefully this guy will rotate. Or the table will, we'll see. Okay, there we go. So we're off the table. You can see the whole table here. We're off the table. So we'll just need to move our piece around till we get it where we want it. What I'm doing right now is just getting this tool positioned in the right spot according to my light sketch on the plate from my template. And I'm going to do what they call a dry run. A dry run is basically letting the machine operate the whole path without cutting anything. And that will make sure that everything is going to basically work correctly and do its job. So let's give that a shot. So we're here, and what we're going to do is do a what they call dry run, and we're going to lock the machine. We don't want the machine to do anything. Okay, before I start, I'm just going to set everything to 0 here. And the reason I'm going to do that is this will basically set the machine to 0. I'm moving the head down to a little bit more close approximation, and then I will also reset this one. Alright, so we're all set at 0. This is going to be my new relative home position, and now we can start the actual dry run. Alright, so hitting start, and this will start the process. What we're doing is doing a dry run like I mentioned. We're going to make sure that the head doesn't hit anything in here, tolerances look fine, we're all okay there. As you can see, the little red arrow here and the numbers changing, we're going to be following this template that I made. And I'm going to speed this up because this is actual run speed, which is relatively slow. So we will actually put the feed rate at 10, and now it's going to go really fast. So you can actually see the machine here. It's actually moving around doing its preliminary test cut. And basically it's going to be running through the process without cutting anything. I want to make sure that everything works well before I start cutting, because once you start cutting, you can't really just stop and restart without getting out things off, because this is a very precise machine. Down to the 1, 2, 3, 4, 5th decimal place to the right of the decimal place. So the dry run worked great. Now we're going to actually let the machine do what it's supposed to do and cut this plate. We'll reset everything back to 0 and get it home, feed the wire. We're going to turn the machine lock off, dry run off. We're going to move. Right now we're at the last state the machine was in, so we're actually going to move this 0.0 3997. Since it's negative, we're going to go positive. That's in the X axis. So in the Y, we're going to be going the opposite. Negative 0.19838. And we're going to start this in this position. We'll end up back at 0 if I did it right. So we're back where we started. And basically, reset everything and let the machine actually cut the material. I'm going to insert the wire. That's a wire collect. Insert the wire. And this might splash. So the wire is feeding, I don't know if you can see that jet, that water jet down there. Okay, so you can see that wire in there. That little bitty tiny 1/2 millimeter brass wire is what's going to be doing the cutting. I'll show you actually real quickly how it comes through the machine so you can get a visual of that. Okay, we're going to start the cut. The wire has been fed. The machine is ready to go. We have turned off all of the dry run capabilities and the machine lock. So basically going to hit this start button and hopefully the machine does its job. The tank is going to fill up because everything must be under water to remove particles from the actual machining process, as well as to keep the, well, that's the main reason actually. This water is actually processed, so it's highly unconductive. The plate that you see here is tied to ground or zero potential, and the wire is tied to a positive voltage potential. The water is highly non-conductive. It's treated through a filter system behind the machine here, and it is highly unconductive. It is designed to not conduct because you want the conductive portion to happen between the wire and the aluminum. Okay, so you can see the ripples in the water. That tells me the jet is running. And the system will start feeding in right now, and there it's actually cutting. You can see the cutting happening. That is actually removing material through an electrical discharge. It is hard to see because it's under this water, but you'll see exactly when we're done what I'm referring to. It's cutting it quite fast, actually. I'm quite pleased with that. All right, you can see our numbers are moving, the machine is moving, the table's moving, and our red indicator here is actually where the wire is at this exact moment in the cut. So if you want, you can actually watch the wire feed spooling and feeding into the machine, and it'll be spitting out the backside if you want to have a look at that. As it goes in, it's nice and fresh and new, and as it comes out, it's all burnt because it's actually discharging electricity and burning the wire, removing material along with it. Okay, so just to give you guys a quick idea, this machine runs off of G-code, which we created in the Bobcam software, which we saw earlier. Let me turn this on. And basically, these are coordinates, X, Y, I, and J. X and Y are actually X and Y coordinates. The I and J are for the radiuses that we're cutting right here. So as soon as this point gets around to the flat spot here, which is actually another radius, then you'll see that this line of code will jump to the next line of code, and then it'll be following that arc until it finishes. It's pretty cool because it's not a point to point to point. You can actually do arcs, which makes the G-code much shorter and easier to work with. And then here's the actual live position of the machine. This is where it's at. They're just switched. So that's how what you're viewing here. Then you've also got voltages and currents, different options, feed rate, the wire feed rate, and a few other things to help you get the machine set up correctly. Just finished. So we will stop it because, oh look, it fell out completely. Good, perfect. So we're going to drain the tank, and we will remove our part and see what it looks like. Yeah, it worked. It's missing. I'm gonna dig it out of the bottom. It's usually always up in the corner. See if I can get it. There it is. So there is our beautifully cut black anodized aluminum plate. Now we'll machine on the milling machine to finish all the holes and such. You could do holes on here, but then you have to pre-drill them, and for this piece it's not necessary.
And how do you know for sure if it cut it correctly?
We could measure it, spec it out, but This is just rough outage cutting, and I'm perfectly okay with it not being exactly perfect, but it is. I can tell you it's correct because I watched the machine run. Told it where to go, it went there, cut. Now we're done.
Okay, there is the excess plate that I cut it out of. Looks pretty cool. Clean cuts, man, clean. So I'm gonna spare you guys the time. Basically, I'm just drilling all the holes using an end mill for the drilling purposes. This end mill does have a center cut, so be aware some end mills do not have center cuts. So I'm saving you the time here. Basically, just running through the whole entire thing. So I'm not gonna, yeah, sparing you the time. So anyway, here are the plates, and worked really well. They look clean. They look nice. They turned out really well. Perfect. So now we're going to do a deburring session. The most important tools that I have laying around here are probably deburring tools. So this type of a deburring tool here is like a 3-pointed sphere that has just sharp edges around it. So you can see how much deburring helps. Look how much I deburred off these guys. So there are the plates. They look beautiful finished. Absolutely beautiful. And I will have to drill these holes to a different size later, so some of them. So here we are just assembling this guy, testing a few things, and I'll give you a little sounds of the sliding so you can hear it. So a few more adjustments here, but seems to roll really well, seems to work really well, so I'm quite satisfied with that thus far. Alright, so if you listen really closely, you can hear this little tick, 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 tick in this footage, and that's actually due to the bearing, the one I pressed in there funny. Remember I told you last time you'll ruin the bearings? Listen to it very closely. That is actually what that little tick noise is. So luckily I have one spare, so no big concern here. Alright guys, so I have been building this printer outside of work hours, but for this particular day they wanted to do some filming. So the reason that this footage is so nice, and you guys I hope enjoyed it, was that there was actually a guy here that's doing a documentary for what we're doing here at my current research facility, which is quantum gravity research. So I'll leave some links in the descriptions. Make sure you go check out those other videos for my other research and what's being published over there. So the gentleman you see in holding the camera is actually our director of media at the current time, and he does a really good job. He's putting together some really cool short edits of different things I've been working on here at the shop. So make sure you go check that out, and stay safe. God bless. Have a good day. We'll see you guys later. Peace.
But first, I must extract the last bit of caffeine out of this messy stuff they call coffee. Yeah. You know, I don't really like, I like the water. I don't really like the brown, but I like the caffeine. Cheers.
Just keep your face unnaturally close to it, though.
Unnaturally?
Yeah, it looks good on camera, even if it feels weird to you. Not that close.
You are filming my cameras, but I am recording my audio. Maybe you'll find it. Maybe you won't. Maybe there'll be cheeseburgers in paradise. Ba-da-da-da-da-da-da-da-da-da-da-da. You know, you could probably be copyright for that.